In this video I'm looking at the solution to question 8 from the June 2011 Edexcel D1 paper. The topic of the question is linear programming. The question says that a firm is planning to produce two types of radio, type A and B, and that they've done some market research so that at least 50 type A radios should be produced, and the number of type A should be between 20% and 40% of the total number of radios produced. We're then told that each type A requires 3 switches and each type B requires 2 switches, but the firm can only buy 200 switches each week. We're then given the profit on each type of radio, type A being £15 and type B being £12, and the firm wishes to maximize its weekly profit. The question asks us simply to formulate all of this information as a linear programming problem, defining your variables. Well, starting first of all then with that defining of the variables, we're told that we've got two types of radio, type A and type B. So if we start off by saying let X be equal to the number of type A and Y be equal to the number of type B produced each week. The objective of the exercise is to maximize the profit, so let P be equal to the profit, and then we need to maximize P, which is equal to £15 for type A, so that's 15x, and it's £12 for type B, so 12y. So we need to maximize P, which is 15x plus 12y, and we would then say subject to the following constraints. And the constraints are given to us in the question. The first one, at least 50 type A radios should be produced. So that's telling us that X must be greater than or equal to 50. Then we have quite a complex one after that. The number of type A radios should be between 20% and 40% of the total. Now the total number is X plus Y. So we're saying that type A should be between 20%, so X should be greater than 20% or 0.2 of the total, X plus Y, and it should be less than 40%, so X is less than 0.4 of X plus Y. There's then one other constraint which is to do with the buying of the number of switches. We're told that we can only buy 200 each week, and type A takes 3 switches, so 3x, and type B 2 switches plus 2y. That must be less than or equal to 200. There's one other constraint that is not actually written in the question. It's the idea of the non-negativity, which is always in a linear programming problem. Now in this case we already have X is greater than or equal to 50. So there's one other, which is the non-negativity for Y. What's called the non-negativity constraint, which is that Y must be greater than or equal to 0. As I say, often it would be X and Y that are greater than or equal to 0, but we already have X greater than or equal to 50 in this question. So that's it. Looking at the way this was marked, there was a B1 mark for defining those variables X and Y, B1 mark for giving the profit equation, and then B1 for each of these three constraints here, and a final B1 here for these final two constraints. So in total there are 7 marks, all B marks, and no method required, just a statement required of the actual linear programming problem. Well, that's the end of the solution to this question. You can find solutions to other questions at www.furthermaths.org.uk.